let's just walk through some of the common encryption strategies. Now, I've been deliberately provocative with the box on the left. And when I say no encryption, I don't totally mean no encryption. Obviously, we're going to use a secure channel on the public internet. We're going to offer our services over HTTPS. But what I can do is I can terminate that encryption as soon as it hits the firewall at the edge of my data center. So in other words, I can perform SSL offload. And then I can be very judicious. I can be very thoughtful about where and when I apply encryption. And of course, there's always going to be places where I do want to use encryption of traffic in motion. But I do also need to think about the consequences of encrypting. It makes it more difficult to ensure the availability of my services. And if I do get a problem, it makes it harder to troubleshoot. But perhaps more importantly, it makes it harder with lots of encryption to identify that I've got an attacker in my network. Attackers love encryption and they're very good at using it. The more encryption you have in your network, the easier it is for an attacker to hide in plain sight. Whereas if you've minimized your encryption to where you really need it, then you stand a much better chance of spotting things like malware, because you see unexpected behavior on the network, lateral movement, pivoting, data staging before an exfiltration attempt, and the exfiltration it represents. So it's all about maintaining maximum visibility. Now, of course, I appreciate many of you work in highly regulated industries such as finance and healthcare. And in those situations, obviously, we're going to have to encrypt some of this information, things like financial transactions, people's financial information, healthcare records. It goes without saying that those will be encrypted both at rest and in motion. And the way we've done this in the past is to use one of the TLS versions, transport layer security, and we probably used static or slowly rotating RSA keys. And this means that it's actually relatively straightforward to decrypt when I need to. I can perform inline decryption, which I'll describe in the next slide, or I can perform out-of-band decryption. And what I mean by out-of-band decryption is either in real time taking a copy of packets and using a server key to decrypt them, or doing that after the fact. I may go to packets that I recorded on an InfiniStream, for example. I need to debug a particular session, then I can go and get the corresponding keys and debug post-capture. Now, the Transport Layer Security Standards are owned and maintained by an organisation called the Internet Engineering Task Force, or the IETF. I'm sure you've heard of them. And the clue is kind of in their name. After the Snowden revelations, the activities in the encryption space of the IETF has pretty much totally focused on the problem of preventing unauthorized eavesdropping on the public internet. In fact, any eavesdropping of any kind whatsoever. And the folks at the IETF have focused on a notion called forward secrecy. And it's a really simple idea. It just says, hey, if I'm going to use keys to encrypt some information, just only use those keys for a really short period of time. That way, if the keys become compromised in some way, they still can't be used to encrypt data from the past or future data. So it's a very simple concept. If you want to think of it another way, think of getting a locksmith to come and change the lock on your front door every day. That way, if you lose your keys, it kind of doesn't matter after next morning. Now, in transport layer security, forward secrecy is implemented using something called ephemeral Diffie-Hellman. Now, the key word here is ephemeral, because the IETF kind of took the notion of forward secrecy to its almost logical extreme. They said, we're going to change the keys for every single session. And that's great on the public internet, but it does actually make life a bit harder inside the data center. I can still perform inline decryption. We'll talk about this a bit more, but it doesn't prevent me from performing inline decryption. But you'll see I've grayed out-of-band decryption. Out-of-band decryption isn't impossible in the presence of forward secrecy, but when it's implemented as ephemeral Diffie-Hellman, it's certainly a lot more challenging. And, you know, I've got a huge amount of respect for the IETF and the people who contribute to the IETF. I have many friends who do so. And I've asked quite a few of them. I said, you know, what sort of happened? Why have you embraced forward secrecy to this extent? Because what they've done is, although forward secrecy is an option in TLS 1.2, it's actually the only option in TLS 1.3. They've effectively made the use of ephemeral keys to be mandatory. And it's interesting when I say, well, why did you take out a really good standard that's useful to us and you just made it kind of a bit harder to use in a data center? And the answer's always been consistent. They say, we are the Internet Engineering Task Force, and as far as we're concerned, our scope and responsibility is about preventing eavesdropping on the public internet. They said, if you want to use our TLS standards inside a data center, that's great, but that is not our primary use case. And some folks even said, you might want to think about maybe a slightly different version of encryption that meets your requirements. And it turns out, we can actually get pretty much all of the benefits of the TLS framework, but retain all of our decryption capabilities. And this is an idea that I've been talking to a number of business partners and customers for a couple of years, and we've sort of named it Managed Diffie-Hellman. And it's a very simple idea. We're still going to perform forward secrecy, we're still going to rotate our keys, but instead of doing it for every session, we're going to do it, say, every hour or every other hour. I still retain the benefits of forward secrecy because my keys still have a short, finite lifetime. But when I want to do things like out-of-band decryption, it becomes much more practical because I'm going to use a key manager to generate those keys, and it can push them to the decryption units, and it can keep a secure history, if necessary, of the keys. I'm not dealing with millions of keys. And the really nice thing about this approach is it is fully compatible with all of the TLS clients, including TLS 1.3.